Hello everyone, welcome back to my tutorial. In this tutorial we are going to solve this truss problem using Salome meca. Salome meca having preprocessor, solver and postprocessor. So solver is a code aster. Now we'll open Salome meca to solve the case. Now see the problem. This is our model. So every coordinate dimensions are specified. We'll create a line to connect this to generate the model. Then the material property is steel of Young's modulus 210 gigapascal and Poisson ratio is 0.3. So we are going to do static analysis using beam element. Now just go to geometry. Here itself we can model it. So first we'll create a point. From that we'll generate a line. So the first point is 0 0 0. The next point is x3 y0. 0 0 0. Next point is x is 3 y is 0. Just apply it. Go to fit screen. First point and second point we have generated. Third point is this point will create x is 0, x is 9, y is 0. Y is 0. Just apply it. Fit screen. See, we have created these 3 points. Now we'll create this point. So x is 0, y is 4. Just apply it. Next point is this one. This one is a sector actually. So 3 plus 3 6. So x is 6, y is 4. Here they mentioned x is 6, y is 4. So x is 6 and y is 4. Just apply it. Now this coordinate is x is 12, y is 4. X is 12, y is 4. Just apply and close. Now we have created these points. Using these points we will create a line. Go here. For that we'll use option called line option. Create line or construction, line construction. So first point. This is the second point. Just apply it. Then using this, use this one, second line. We'll add this coordinate for AC. Then use this one, just apply it. Then we'll make this one, just apply it. And there is a point here, just apply it. Now just go to the model. We just want to connect this one. So select this point and select this point. Just apply it. Select this point and apply it. Now we have created this line. Finally we just want to make one triangle here. So just 2 lines we need to make. Using this point and this point, just apply it. Then you just select this point, apply and close. So this is our case. So this is our model. Using this we need to analyze it. So now we have created this 9 lines. Make a single line using build wire option. Build wire. Just apply and close. Now we got this wire. These are having different lines, but we have built into a single wire to analyze into a single component. So we'll save this file. Go to file, save as, pictures, code aster, trusses, 5th problem, study 1. I have saved it. Now we'll create a groups to apply the boundary. Create group. First we'll create edge group. Select all. Truss. Just apply. Now go here. We need to apply only fixed boundary condition to this particular edge. and two forces here. Only 3 boundary conditions. One is constraint, another one, 2 are loads. Go here. This edge we need to fix it. Add, fix, just apply it. Now just go here, this point and this point. Select this, go to point constraint, save type is point. Select this point, just add it. Force, just y1, just apply. This one is add it here, force y2, then apply and close. Now we have created all the groups. This is, we will check this one by one. So this is truss, this edge is, we need to fix it. This is the force y1, this one is force y2. So now we have done modeling and creating groups. Now we'll save this file, we'll move into meshing model. Now select this wire 1, go to mesh, create mesh. So go to wire discretization. Now we'll use number of segments. I just want to divide every edge into 15 number of segments. So I just make into even number 16. Save OK, apply and close. Right click, compute. Now it has divided into 141 nodes and 144 edges. That is, we can check by using modification, add node. So this is the way it has divided every edge into 16 number of segments. It is divided into 16 number of segments. So now see, now go to mesh 1. So these two are nodal groups and these two are edge groups. Now just save this file. Now we'll move into aster study. Aster study. So choose code aster version. It has stable, so I am giving stable. Now we'll add stage one by one. Add stage, mesh, read mesh. We need to read the mesh. Mesh file format is MED format. Just apply it, save OK. Now go to model definition, assign finite element, edit, everywhere it is mechanic, and we need to make POU-DT, Timosika beam element. Save OK. Mesh we can keep, just apply it, save OK. Now we have defined the model. We need to define the element type, element property. Go to FEA element, element property. This is beam element. Edit. Section is the rectangle section. So Kara. Here. So here we can choose HY and HZ. If you are having thickness, we need to specify EPY and EPZ also. So HY and HZ, the value is 0.1 and 0.1. Now we need to define group of elements. The first one, go to edit, truss, say OK, just OK it. Now we have defined, here model is there, just apply it, save OK. Now we have defined the element property. Now we need to define material and assign the material. Define a material, linear isotropic, edit, Young's modulus is 210 e power 9, Poisson ratio is 0.3. Save OK, just apply it, save OK. Now we need to assign the material, mesh, model, make sure you are ticked and go to plus edit, apply to everywhere. We can choose the group of element at Truss also, but anyway we have only one model, so for that we can use everywhere. Choose material, just apply it, save OK. Now we have assigned the material to the mesh. Then no, there is no function and list we are going to use here. Just go for boundary condition and loads, assign a mechanical load. So here just go to the problem. Here we need to completely fix. We need to apply two loads. So one load is here 5 kN, the another load is here 5 kN. Just go here, enforce degree of freedom, edit. So group of edges, so we have element, so fix is the element group, say OK. We need to fix it, these all 0 0 0 0 0 0. Then say OK. Fixed boundary condition is done. Now we need to apply force. There is an option called force nodal, edit, group of nodes, the force y1, this node, say OK. In y direction the force value is 5 kN. In negative, because it's downward, 5 kN, just 5000 Newton. Say OK. There is one more force, just add it here. Go to edit, group of node, edit, force y2, see this node, say OK. This also 5 kN, minus 5, 1 2 3, 5000 Newton. Say OK. Just apply it, say OK. So this is the boundary condition we have created. Now we need to specify, and pre-analysis not required. Just go to analysis, static analysis. We have to include everything: material field, element property, model. There is option called loads. Go to plus button, edit, include this load, say OK. Just apply it, say OK. Now we have defined the solver also. Now just go for post processing, call champ, constraint. Here we need to choose FGLA SIPO element, SIPO node. There is option called reaction force. Just go to reaction nodal. Remaining thing, just make it enabled. Just apply it, say OK. This is actually unnamed, it came. Give the same name, rest lane. Just apply it, say OK. Now we'll do the saving the output results. Go here, set output results, just tick this three dot, go here, pictures, code aster, Truss 5. I'm just giving result.rmed. This is the file format for reading result for paraview. Go to this one, edit, choose the mesh, choose the result as meca static, change into calcam, because calcam is calculating from all and it has displacement also. Go to this element property and there is option called toucham, make it S. Now just scroll down here, just say OK. Make this format to MPD, just apply it, say OK. Now we have defined the case. Now we'll solve this case here. Go to history view, click the plus button, keep it here, make this into 5 seconds, run it. Now it started solving. Now it has solved and results are saved without any alarm and error. So now we'll go for post processing paraview to view the results. Open pictures, code aster, trusses, fifth case, this one, save. OK, just apply it. So this is our model. Just go here, go to displacement. Now why will have the maximum displacement? So because we are applying load here and here, so maximum displacement is minus 3.4 into 10 power minus 4 is coming in this location. To view the results in rainbow, green and red, go to rainbow, blue to red, just apply, close. So to this point we make it 12. Similarly, go for stresses. You can see the stress here. This is normal stress. This one is the bending stress in Y and bending stress in Z direction. This is torsional stress. These two are shear stresses. So which one you want to check, you can check it. I just want to see normal stress. So normal stress is these two element is getting tensile stress 1.5 e power 6, so 1 megapascal, and these two stress element are getting compressive stresses, that is around 2.2. so some of the elements are getting zero stress, so almost these are getting zero stresses. So reaction force we are fixing here, these two edges, this complete edge we are fixing, because we are applying load here, we are getting reaction force in these 2 points. So if you want to see the reaction force here the red color indicates that the reaction force is 2.5 e power 4 is a maximum reaction force. If you want to check the reaction forces here, so just go to view, make sure you have selected the selection display inspector, and here you just go reaction nodal. Now we just go for selection option. There are different way we can select. Now I just want to select a node, just zoom it. So use the control option to press the hold and use your mouse roller and making front rolling, you will get this zoom option. So now select this node. Now it has both horizontal reaction as well as the vertical. This is the horizontal reaction force. We'll check once here, reaction nodal. This is horizontal reaction force, and this one is the vertical reaction force. Similarly, we can check the reaction force here. Here also we are having both the reaction force. So this one is the horizontal reaction force, this one is the vertical reaction force. Here the vertical reaction is almost 17 Newton. Horizontal reaction is very much higher. So similarly you can see that here. So in that we have seen a truss analysis of using Salome meca. So in next tutorial we will see the different case. Thank you for watching my videos. Please subscribe my channel for more videos. Thank you.